Today's problem, we'll be looking at problem 268, missing number. As per usual, the 3 steps of solving any problem are 1. Understand it, 2. Visualize it, and 3. Implement. Given an array nums containing n distinct numbers in the range 0, n, return the only number in the range that is missing from the array. There is one number missing. Example 1, 301. The reason 2 is missing is that there should be a 2 in there, 0 to n being 3 in this case, because the length of the array, we don't see 2 there, so output is 2. In this case, 0, 1, n is 2, so we don't see 2 here. The output is 2. Here, just same thing with like a whole bunch of numbers. The constraints: n is the nums.length, n is between 1 and 104, and the value of each nums value, the value of each number is 0 and n, and all the numbers of nums are unique, so there's no repeating numbers. And the follow-up: could you implement a solution using only O1 extra space complexity and On runtime complexity? So O1 extra space complexity means like don't add any kinds of like hash tables or different ways of just like keeping in memory some kind of data that runs at n time. Like it could be up to n number of extra pieces of data, and then On runtime complexity. So like linear, can you keep this linear? So what are the clues we have to figure out the best data pattern to solve this problem? So the first one is that the value of each number is between 0 and n. And the reason that is useful is that it already indicates that we could try to map numbers to their index values and then just see which one is missing. So here's an example. Let's look at the first one, 301. So let's say we move these guys around, move that guy there, and then I guess we'd have to put this guy here because we can't push it any further. There's 3. So we look at 0 at its correct index, it's good. 1 is at its correct index, it's good. And then at this index, like it should be 2, we should see a 2 here, but we don't, we see a 3. So then we realize that 3 is that 2 is the missing number. Let's say we saw 0, 1, 2. We see that 0 is in the correct place, is in its correct place, 1 is in its correct place, 2 is in its correct place. So the only missing number at this point is n, which is 3, and n once again is the length of the array. And really that's all there is to solving this problem. Like we just have to figure out a way to map our numbers to their index values, and then just check which number is not corresponding to its index value, and that should be all the info you need to say which is the missing number. And the strategy to now map numbers to indexes is this simple data pattern called cyclic sort. And the way that works is, okay, let's take 013 again. Sorry, what was it? Oh, 301. 301. So it's an iterative pattern where what you do is, so you're iterating through numbers. Like, okay, let's actually start with a slightly simpler example. Let's do 201. So we look at the first number, so it's 2, and we ask the question, is it at its correct index place? So no, it's not. It's so at this point, let's just swap it out to its correct spot. So it should be here where 1 is. So let's just swap those 2 values. So 1 goes here and 2 goes here. And then now we look at what's in this place now, and it's a 1. We ask the question, like, is it in its correct index place? The answer is no. It should go here where 0 is. So swap those guys. And now we say, is 0 in its correct place? Yeah, it's good. Is 1 in its correct place? Yep, 1 is at the 1 index point. And then 2 is also at its correct index point. So that's the pattern called cyclic sort, and that is all we need to solve this problem. So let's just implement exactly that. So, off the top, we're going to need a swap function. So let's just get that set up. Just boilerplate stuff. Nums left equals nums right. Nums right equals temp. Okay. And now we can iterate through our array. And we want to use let I equals, as opposed to saying like let num of nums, because we want to keep track of the indexes. I equals 0, I is less than nums length, I plus plus. Oh, and you know what? We actually want to use a while loop, because if you think about the problem we had, like 2, 0, 1. So we said, wait, 2 needs to be swapped with 1. Then we saw that 1 needs to be swapped with 0. So we didn't, like, when we finished the swapping, we didn't move our iterator yet. We want to make sure that that we're totally happy with the current index value before we proceed to the next guy. So let's actually do let it's for iterator. So while it is less than nums length. So very similar to a for loop, just has that little nuance there. We say if nums it does not equal to it, then we want to swap, and we want to swap these guys, those two. Else we want to, we're happy with, that means it's at its correct spot, and we just iterate forward. And one little nuance in this in this arrangement is that nums it will be undefined if the number is 3. So let's say we had this 3 here, we would ask like, oh, is nums of 3, like nums 3 equal 3, but obviously like nums 3 doesn't exist because it's it would be undefined. So we do gotta double check that that this value exists, and nums it is less than nums length. So this will still work. Like, it's just gotta check for that, because it would cause a loop, because you just keep getting in the undefined is not equal to 3, and it would just keep looping. So we need to add that. But at this point we are sorted in the cyclic sort kind of way, and so we can just say for I equals 0, I is less than nums length, I plus plus, if nums I. So at this point all the numbers should be corresponding to their indexes. So if they're not, it means that it's not in its correct place. So we return, we're going to return this guy. Return this guy or the iterator? Let me just and then in the case of that none of those happened, this would be the case of like 0, 1, 2, we return the length of the array. So that's what this is. And then let me just think about this. So I equals 0 less than. Oh yeah, this is the missing number. So we need the iterator. So that's why we return that guy. And then example cases. And we submit it. And there you have it. So that's missing number. We use cyclic sort. So thank you, and catch you later.